Hi everyone. This is Mrs. Nesser. Welcome back to class number 2. I hope everyone had a nice first week of classes. You got settled in and you're starting to find a routine. Good luck with everything. I hope everyone stays safe out there. Couple things. First, as you're establishing your routine, I really do think it's beneficial for you to get into a routine. So whether or not you watch these videos at 4 o'clock, maybe you log on, watch your video, do your quiz at 4 o'clock. Or maybe you have a different day of the week that you do it. But I would get consistent with it because I am kind of strict with these times. Have been receiving emails from everyone of quiz number 1. So quiz number 1 is due today. So notice it is due by 6:30 today. So that would be the quiz from last week. So all the videos and the material from the videos from last week. But that quiz is due by 6:30. And for those of you that already emailed, thank you for that. I will have those quizzes graded by next class. So at some point during the week, you'll see the grades for those pop up on Schoology. So just keep up with that. And then, of course, today, today I will cover sections 1-3 and 1-4. And then today's quiz, again, likewise, won't be due until next week. Okay? So again, hopefully you're watching these videos. Hopefully they're not too terrible. But today I'm anticipating 3 videos. There may be 2. We'll see how it falls here, but I'm anticipating 3. Anyways, without further ado, let's move right along. Okay, so last week I did do word problems, and I promised you guys the answers to those. So I will upload the word problems as a PDF on the file as well. But I wanted you to see that here they are. So you'll see the ones that I did last week, and you'll also see the homework ones. So feel free to check your answer. Look at the work. Make sure you have the correct work. Because when the test comes, when the quizzes come, you do have to show me your work or your we always say show me your thinking, because there's different ways to do math. But as long as you're showing me how you arrived at the answer or you're thinking what you did, then you will get credit for that. Okay, so here's the answers. Like I said, I'll post this file separate on Schoology so that you could download it and see it. So it will be labeled Chapter 1 Word Problem Answers. Okay, so moving right along. So before I go into section 1-3, I want to take a jump back to section 1-2 from last week. It has something to do with set notation. I like to do this the second day, so you may have seen this on the homework. I believe there were a couple examples in the book. But I kind of wanted to go over this now just to kind of review this little bit with set notation and the whole brackets and parentheses idea, because sometimes interval notation is a little bit confusing. So we're going to go ahead and start off with set notation. Set math is something that's usually done maybe in a statistics course or probability course. But this little part of your book, they do mention it. So we're going to go ahead and go over it. So first, 2 definitions here. And the first one is union. So if you have sets A and B, the union is all elements of both sets. So what I like to say, I'll compare them here in a second, but the key word here is all. Okay, all elements. The other word, contrast to that, is intersection. So if you have sets A and B, and you can actually have more sets, but we'll just say 2. So if you have sets A and B, the intersection is the elements in common. Okay, so the key word being there, in common. So what do the 2 sets have in common? Okay, so I like to contrast this. Think of college. Think of classes you have with certain people. So take two classes. So take this class, and I'm sure there's some of you out there that have another class together with somebody else. So if I say, what's the intersection of you, of this class and your other class, you may say, oh, me and John, we're in the same class together. So we're in the intersection, we're in common. Now, if I do the union of those two classes, this is the fun part. We just say we're having a big party and everyone's coming. Okay, it's just everyone. Everyone in the one class and everyone in the other class. So union, just by definition, when you have a union, you have a get together. So kind of think of that. Union is everybody. Intersection, I spelled that wrong now that I'm seeing this. Intersection is the elements only in common. Okay. Furthermore, there are symbols for both of these words. So the symbol for union is just a U with no little tail on it. The symbol for intersection is the upside down U. Okay? All right, so let's look at an example. Okay, so what is this going to look like, okay, if you were to see it? All right, so an example, and we'll do two here. So example one, let's say set A, and I'll go ahead and use numbers here. And set B. And you could do numbers, you could do letters, you could pretty much do anything, but all right, so let's talk about this for a second. So set A is from -3 to 3. That is an interval notation. So that means there's -3 in there, there's -2 in there, -1's in there, zeros in there. They're all in there. And also -3 and 3 are also in there because of the brackets. They are also included. Now take a look at set B. So set B is from 0 to 5. Now, 0, 1, 2, 3, 4, 5. However, is 0 actually in there? What do you think? No. Because if you remember from last week, the parentheses mean that it cannot include the number. So 0 is not in there. So some of the questions that would look like here, I would ask you to find. So question A may say, find that. And that might look like a word to you. But again, that is the union symbol. So A union B. What is in all of the sets A and what is in all of the sets B? Part B may ask you to find the intersection. What is in common between sets A and set B? Okay? Well, the easiest way to do this, I have found, is do a number line. So what I would do is I would do a big, gigantic number line. And I always put my smallest number. So I look up there and I say, oh, my smallest number is -3. And then I keep going. So yes, you have -2, da, 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 da. You would have 0 at some point. 1, 2, 3, 4. And my biggest number would go the whole way to 5. Okay, just to kind of get an idea. Okay, and what I do is color code this. So set A, and you can use solid line or dotted line or pen or pencil. So set A would go from -3 to 3, and I would draw a graph. I think visually is probably the easiest way to do this. So -3 to 3. Now, someone out there, why am I drawing closed circles? Because that means the bracket is included. Okay, the number is included in there. So I can include -3 and 3. Then I would pick a different color for the 0 to 5. So let's go ahead and graph that one. So that goes from 0 to 5. And I'm going to graph it right on top. Now again, why am I drawing open circles here? Okay, because I have the parentheses. So it cannot include 0 or 5. Now, looking at this picture, when you do union, union is from start to finish. That's it. And it doesn't matter what happens in between. Where does this picture start? Right here. Where does this picture end? Right there. Okay? You're looking at the whole picture as if it was one gigantic graph. So the union is from -3 to 5. And now you have to just be very careful about the brackets. If it's a closed circle, it's a bracket. And if it's an open circle, it is a parenthesis. Okay? Now contrast that with intersection. If it was intersection, you are looking for the overlap. Okay? So where does these graphs overlap at? And it's kind of like right here. So I like to kind of shade that from there to there. So basically from 0 to 3 is where that overlaps at. So 0 to 3. Now you have to be careful again about your parentheses and your brackets because there's an open dot at 0 that would have to be open and 3 would have to be closed. And you successfully have found the union and the intersection. And 0 does have to have a parenthesis because technically he's in set A. 0 is actually in set A, but 0 is not technically in set B. Okay, you can get very close to 0, but it cannot equal 0. Okay, one more example with some infinities here. So example 2. Hypothetically, if I gave you set, let's do D is -4, 1. Whoops, let's do a parenthesis on that. And let's do set, let's make it F, 2 to infinity. Okay, so again, I want you to find the intersection and the union. So we'll do the union, and then we'll do the intersection. Make sure you know these symbols and which is which, because I don't tell you that. So that's union, obviously, and then that would be the intersection. So when you're taking a test, just make sure you know which is which on that. Okay, so again, I like the graph method. I just think visually, it's easier to do that way. So here's my number line. My smallest number up there is -4, and I'm going the whole way to 0. I go to 2, and technically you keep going. So we'll just kind of let that go there. So if I was to graph D, -4 to 1, close circle at -4, and it's going the whole way to 1. Now that's going to be an open circle there. And if I was to graph set F starts at 2, and it goes to infinity. Okay, so if I'm to look at this graph, union, remember, you look at the overall picture as if you were to merge those two together. So what is in the union, okay, of this graph? And I don't know if I want that to go to 1. Yeah. I guess we could do it. Okay, so union. If I was to merge these two graphs together, this graph starts at -4, and it goes the whole way. Now, right here between 1 and 2, is there any number in between 1 and 2 in either of these? So say 1.5 for that matter. Is 1.5 in either of those sets? And hopefully you're out there saying no. So 1.5 is not in there. So technically the union, if I were to merge these sets together, goes to 1. And here's where the break comes. You have a U, and then they'll go 2 to infinity. There's nothing, you cannot really merge those together because there's actually some numbers that aren't in there. There's a break, okay? And that U does represent the break. So you will see that when we start doing inequalities here. So I kind of wanted to just kind of get that out there a little bit. And intersection, as far as intersection, is there any intersection between these sets? Do they overlap at all? No. So that would actually be called empty set, or no solution. And that's where the empty set comes from. Okay, so there's no overlap there. They don't overlap whatsoever. All right, now I could modify this example slightly though. Okay, so what if I had set A, or set, let's add another set here. Just so you can see another one here. Let's do set, let's add a set E. So let's do set E -1 to 3. And let's keep our set F 2 to infinity. Oops, that's a bracket. Okay, so, and you can see the difference then on here. So again, let's find the union, and let's find the intersection. Okay, so as far as the union and the intersection. All right, so let's look. Here's my number line. I'm going from -1, 0, 1, 2, 3, and then technically to infinity, so that should be enough. Set E is -1 to 3. Cannot equal -1. Closed at 3. And set F is 2 to infinity, so closed circle at 2, and that would go to infinity. Okay, so as far as union, they do overlap. So all those numbers are contained in there. So technically this graph starts at -1 the whole way to infinity. Okay, if I were to merge those graphs, and I can actually, since I'm on a smartboard here, I can take this red line and I literally can just throw it on top and merge them, and you can see that they're all in there. Okay, so that is basically the union from start to finish. Intersection, again, is just where they overlap. So they overlap from 2 to 3. And so that would mean a bracket at 2 the whole way to 3, and a bracket there as well because they're both closed. So that would intersect, that little piece right there would be your overlap. Okay? All right, so I kind of wanted to go over that. I think there were a couple homework problems, so I didn't want you to kind of see them and say, oh my God, I have no idea, I didn't see this, but that is the idea right there. Okay? All right, so let's go ahead and jump into section 1.3. So section 1.3 is absolute value. So absolute value. When I say absolute value, what does that mean to you? Absolute value. Does anybody know what the symbols look like? Absolute value. Yes, the bars. Okay. So, and you probably remember something from high school, absolute value. You probably remember, oh, it makes the number positive. It makes the number positive. It does. Okay. I kind of don't like that description, but it does make the number positive inside. However, more technically, it is the distance from 0. Absolute value is the distance from 0. All right, so, and that's why it's not negative. Because, okay, so say you're at St. Probably most of you are at Latrobe right now, or at St. Vincent. So if I say Greensburg is 10 miles away and Latrobe is -10, the other direction, we don't say that. Okay, we still say we're 10 minutes away. We don't speak, well, I'm -10 away. No, you're not. It's the other direction, yes, but we don't actually say that you're -10 away. So that's the difference. It is distant, and that's why it's positive. Okay, so, and that's kind of the idea. So just the underlying meaning there. So a couple examples, just to absolute value, to throw it out there a little bit. If you have the absolute value of a positive number, of course, it's just positive. If you have the absolute value of a negative number, of course, that's just 3. So how far away are you from 0? Okay, from -3, I'm 3 spaces away. Now, the misconception, I think, falls when you have a math problem in here. And I see this a lot with my 9th grade. If you have 8 minus 5, say. Okay, kids just so badly learn that, oh, it makes everything positive. It makes everything positive. They turn that minus sign into a plus, and then they write 13. No, 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 no. You have to do the math first. Absolute value has to have one number in there. You must do the math inside first. Okay, and then you apply the absolute value bars. So that is 3, and then that leads us to get 3. And where this is a concern is usually if I would flip something around. So if I would flip that around and do 5 minus 7, kids see that as 5 plus 7, and they write 12. Okay, big misconception. Do the math inside first. So if you do that math inside, you get -2, and then you can apply the bars and get 2. Okay, so not 12. I don't even want to write this down because I don't want you guys to do it. Okay, so you can't just make that 5 plus 7. Okay, no, 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 no. Like I said, I have to erase it. It gives me anxiety. I can't even write it down. But I see a lot of misconceptions on that. But you have to do the math inside first. And that math problem inside could be as lengthy as I want it to be. Okay? So that's the idea. So keep that in mind. I don't know. I've seen that places, but you have to do the math inside first. Okay, so we're going to start off with equations first, because equations are really, really easy. All right, so absolute value equations. And we're moving right along in math. We've done linear equations, linear inequalities, and now we're moving right along to absolute value. So let's do absolute value equations first. So equations, again, means there is going to be an equal sign in the thing. So let's go ahead and look at absolute value equations. And again, there's a couple different ways to teach these, but typically I learned this way, and I think this is the easiest way, so we're going to go ahead and go with this. So as far as absolute value, you have the absolute value of x minus 4. And I want to take a side note, and I want to jump over here real quick, and I just want to make you think for a second. If I gave you the absolute value of x equals 5, okay, what could I put in for that x to make that completely true? What are the options for x? X could equal what? X could equal 5. If I put a 5 in there, 5, absolute value 5 is 5. What else could I put in for that x? X equals negative 5. Because if I put a negative 5 in there, what do the bars do? They turn it to positive 5. Okay, so what did you just discover? How many answers are there? 2. I've always learned in life that absolute value typically will have 2 answers. Okay, there's some might be 1. There are times where you could have 1, and that would be if it would equal 0. Okay, because there's only 1 0. There's not a negative and a positive 0. However, there are typically 2 answers. So what that means, when you have absolute value, I want you to study something for me. Absolute value is a great indicator that you are going to have 2 problems and 2 answers. Okay, this question right here is on your final. And the number one thing people do, they forget to do 2 problems and 2 answers. Guys, this is not linear. This is not like a question I put on last week. There's bars around it. Something different. You can't do the same thing you did last week because it looks different. Okay, math is all about patterns and looking at things, and you cannot do this problem the same. So the first step is to drop the bars and create 2 problems. And usually when I create my 2 problems, I write them separate. Take the time and just write them out. X minus 4 equals 9, and x minus 4 equals negative 9. Okay, now another big thing. Did I touch this minus sign inside the bars? No, I did not. And you cannot touch that minus sign inside the bars. And it goes back to this theory. Can I touch this minus sign right here and make it positive? No, I can't touch it. Okay, you don't just make random things positive inside bars. You are not allowed to do that. It comes off of the answer, guys. If the answer is 5, you have a 5 and you have a negative 5. Over here, the answer is 9. So guess what? You have a positive 9 and you have a negative 9. Those are your 2 problems. Now you can solve the problems. Add 4, you get x equals 13. And over here, add 4. Be very careful though, you get x equals negative 5. Okay? So a couple things. Do not touch that inside. I can't stress that enough. Okay? You can't touch that. I had a middle school teacher once. She said it was in jail. You can't touch them. Can't go visit them, and you can't touch them. So, but as far as that, you cannot touch that inside. Okay, so, but you do have to remember that there are 2 problems, 2 answers. All right, so I got one more for you. 2 problems, 2 answers. Let's see. Okay, so let's try this one. So x plus 3 equals 10. So my first clue is, oh, hey, here's the absolute value bars. I have to have 2 problems. One is x plus 3 equals 10. The other one is x plus 3 equals negative 10. Okay, remember, 10 and negative 10. You always use the answer here. Okay, so once you have your 2 problems, then you can work backwards. Subtract 3, you get x equals 7. And over here, again, subtract 3, and you end up with x equals negative 13. Two answers, two problems. There are two solutions to that problem. And that is the mathematical way of finding it. Yes, you could go back up and see if both of these answers work. Plug them in, do your math, make it positive. You should get 10. Okay? And again, these can get a little bit more difficult. Your book doesn't go into getting it more and more difficult, but they can get difficult. And they can have actually numbers outside of here. So if you would actually have a number outside the bar, you would have to get rid of that number first. Okay, so that's called isolating. And you're going to see that actually when we get to square root equations. But if there's anything outside those bars, you've got to get rid of it first. So for example, if I did have that 2 there, I would have to divide both sides by 2 first, and then that other side would be a 5, and then I could go do the problem. And that might be actually worth mentioning just to kind of show you that, because in higher mathematics you would see that. But for example, so there's the 2. If I would happen to have that 2 outside of there, you would have to get rid of that 2 first. And you would just divide both sides by 2 since it's multiplied. And then you would create your problem from there. Okay, so x plus 3 equals 5, x plus 3 equals negative 5, and then you would go to town. So x equals 2, and then you have x equals negative 8. And again, I could spend all day on these. I could just get more and more complicated, but I think that's to the level that you are going to need for this class. Okay, so that's kind of the idea. Absolute value equations aren't that bad. They're pretty self-explanatory. So just don't forget to write the 2 problems and the 2 answers. Okay, I'm going to go ahead and do the next part of this since I'm only at 26 minutes. So I think I might be able to accomplish it here. So the next part is going to be absolute value inequalities. All right, so a couple things here. So when I see absolute value inequalities, the first thing I see is absolute value. So if I see absolute value, it means I'm going to have the bars, and it means I'm going to have 2 problems, 2 answers. Okay, so you are going to have that. That's just standard. That's what absolute value means. When I see the word inequality, I now know I'm going to have less than or greater than, so I'm going to have stuff like this. Okay, so now I'm not going to have an equal sign. I'm going to have that. So what comes in with that? Well, what came in with inequalities last week? We graphed, number line, interval notation. Yes, you are going to see all of that again. Okay, so it's kind of a nice review from last week because you're going to see all of that again. Okay, so let's contrast this and let's throw a problem up there. And I got quite a few here to talk about for this one. So let's start off with example 1 for this. And we're going to go and do x minus 2 is less than 6. All right. So as far as creating this, it's kind of an idea that you're still doing the 2 problems. And that's like how I like to teach these. I like to stay consistent. And in my head, when I see absolute value, consistency to me is 2 problems right away. So how do I do that? Well, x minus 2 is less than 6, and x minus 2, now wait a minute, I don't have an equal sign there. Okay, so if you have an inequality, you have to flip the sign and the sign of the answer. Okay, you have to flip the inequality sign and the sign of the answer. And that kind of tells you that, okay, the answer could either be here or here. Those are all how far away from 0 that you are. Okay, you're either to the left or you're either to the right. And when I split my problems, I always split them like that. Okay, so again, don't forget the sign and the sign of the answer. All right, so once you have them split, then you can just work backwards. Do 1 problem at a time. X is less than 8. Jump over here, add 2 to both sides. You get x is greater than negative 4. Okay, guys, there's my inequality notation. Okay, when inequality pops up, you could also express this on a number line or graphically. So if I look at a number line, Negative 4 comes before 8. So negative 4, then you would get to 0, then eventually you would get to 8. And as far as graphing, this is going to be an open circle at negative 4 for this piece over here. And I'll go ahead and do a different color so you can see it. So open circle at negative 4. And I'm going to go to the right. However, let's take a look at the other piece. The other piece is an open circle at 8, and it's going to the left. These are going to merge. These are going to overlap. Guys, that is an AND graph. Okay? AND does overlap. Okay? So as far as interval notation, where does this graph start? And it is just the overlap. Okay, so you should not include anything past the negative 4, past the 8. The answer has to be less than 8 and has to be greater than negative 4. Just the overlap. Okay, you can't extend the areas past that. So the interval notation then would be from negative 4 to 8, and both of those would have parentheses because they do not equal. So these are this is interval notation. Couple ways of representing it. There's the graph, and then of course there's the solution that you would get. Okay, example 2, just so you can see a contrast on this. I like to do example 1 and example 2 together, and I like to talk about them for a second because there's kind of a neat little pattern here. So let's do x minus 2 is greater than 6. And yes, guys, this is the same problem. I'm well aware. I do it on purpose. Okay, so absolute value, 2 problems. Ready? What are they? The first one is x minus 2 is greater than 6. Guys, do you remember what we change? X minus 2, change the sign, the inequality sign, and the sign of that answer. So it has to be less than, and it has to be negative. Okay, so if I work backwards, I add 2 to both sides. Get x is greater than 8. Add 2 over here. I get x is less than negative 4. Okay, there's my answers. On a number line, what does this look like? Okay, so let's go to the number line. And we have negative 4's here, 0 somewhere there, and 8, of course, somewhere way up there. Okay, so let's graph this one first. Negative 4, open circle, and my arrow is pointing to the left, so less than, that would go that way. And next one is an open circle with 8, and x is greater than, so my arrow is going that way. Oh, my graph looks different now. So now my graph went opposite directions. This is called an OR graph. OR goes opposite. And it means your graph could either go this way or this way. There is no overlap and they will never touch each other. Okay? So what does this look like in interval notation? So interval notation is going to start at negative infinity. You go the whole way to 4. And union, there's the break. Or it could start at 8 and go to infinity. And it's as if I'm just walking along the graph. I start way down here. I can walk the whole way to negative 4. Can't equal it. But then I have to pick up my pencil. So that is a break. Hence, that's why you have the U. And then you can start again at 8 and you can go the whole way to infinity. Okay, so now here's the good news. Your problem will be either one or the other. There's no between, guys. It's either going to be an and one or it's going to be an or one. Okay? And there's actually a trick on determining which is which. So I'm going to end that there. And then the next video I'll continue and kind of build on it a little bit more. But take a look here. Let me get a highlighter out. And again, I can't take credit for this because another teacher did it. So I can't really take credit, but it's pretty cool. So take a look at example 1. That example 1 there, if my board would actually pick up here. There it is. Okay, so my example 1, that sign is a less than sign. You get it? Less than. Yes, a less than is probably always going to be an and. It's great test-taking strategy, kind of to check yourself on that. So when you actually do your math and you pop out your graph, it should overlap. Okay. And if you take a look at example 2, that sign is a greater sign. It's a greater than 6. So if you take a look at that, my board actually catches up here. It's kind of in slow motion right now. Greater, okay? If you see a greater than sign, it's going to be a greater, and it's probably going to pop out as an opposite. Okay, so the graph will actually go opposite. All right, so I kind of wanted to end there because I thought that was a cool little trick. So again, if it's less than, it is and. If it's greater than, it does pop out to be an or. I will do quite a few of these examples in the next video as well before I go on to chapter 1.4. So I am going to stop it here, and I will see you in the next video. Well, not really see you, but you'll hear me in the next video. Okay, guys, stay tuned.